Yeah, once again, good afternoon all. Good afternoon.
Good afternoon, sir. Good afternoon, sir.
Good afternoon, sir.
In continuation of last class, today we are going to understand normalization. Here, again, just I am repeating earlier what we have discussed. You know, the functional dependency. The functional dependency is very important mechanism. So based on the functional dependency only, we are going to identify redundancy is there in our relation. Means if the functional dependency is existed in the relation, that there is a compulsory there is a chance of redundancy, and that redundancy you can avoid with decomposition of your relation. Sometimes we cannot identify the functional redundancy, functional dependency in a relation, even though there is a redundancy is there, but we cannot remove the such type of redundancy because based on functional dependency only we can remove the redundancy. All of you got my point? Hello?
Yes, sir.
Yeah, because I am telling again, I am repeating. If relation contains means relation, you are identified a functional dependency in a relation, then you can decide it. We can avoid the redundancy with help of decomposition. If we are not identified any functional dependency, that relation also contains the redundancy, but we are not identified functional dependency, so that we cannot solve that problem. We cannot avoid that redundancy. So that is the main context we must be understand based on the last class. All of you clear this point? If you are not clear, note it down. Because this type of information you cannot get any textbook. This is all are based on experience, problem solving oriented. All of you clear this point? All of you clear this point? Hello?
Yes, sir.
Yeah, one more point also I'm going to add here. Don't expect every relation contains functional dependency. Some relations are having functional dependency, some relations are not having functional dependency. Here, as a developer, as a designer, you need to identify functional dependencies are there in that particular relation. If the functional redundancies are there, compulsory there is a redundancy is there. Even functional dependency is not there also, there is a chance of redundancy. But the difference is when you are going to identify a functional dependency in a relation, damn sure you can avoid that redundancy with help of decomposition of your relation. If you are not identified functional dependency on the relation, there is no chance to avoid the redundancy of that relation because we don't have any option to avoid the redundancy. But if you identify functional dependency, we have the option for the avoiding of redundancy. Here, this is small information. People will confuse. A lot of people will confuse this normalization. Actually, normalization is very. If you follow my lecture, if you understand my points and note it down, these points also you will not get in my notes. Whatever now I am telling. All of you clear this? All of you clear this? Hello?
Yes, sir.
Yes, sir.
Now you can understand what is the importance of functional dependency. Means whatever the relations you are implemented, yes, it is fine, 100%. But really, if you identify functional dependency, there is a chance you are having more chance to avoid the dependency because based on functional dependency, you can decompose. Already I told you that decomposition is nothing but dividing the table into multiple tables based on the functional dependency. Here, how to calculate the, how to identify the functional dependency, just now we discussed in the last class. Here, that is Armstrong axioms. You can use your mathematical formulas so that you can get more functional dependency. Based on that, you can avoid those redundancy. You know already here what is the, why the redundancy is there in your relation, what are the problems we get. Can anyone tell? If your relation is having any redundancy, here what are the problems we can expect? Any one of you? Quickly, don't waste time. If relation is having, what are the problems maybe we will get? Problems of redundancy in a relation. So this is third class.
Accuracy during updation or insertion or deletion.
Yeah, anomalies of insertion, deletion, updation, and one more one. Anusha, one more you forgot. What is that? Storage. Clear? Hello?
Yes, sir.
Yeah, please. Please respond. Otherwise, I cannot understand you are following or not. Please. So again, I am telling you follow, ask me the doubts, and respond the things. Right. Here, these are the four problems will come. To avoid these particular problems, we need to decompose the relation. When you want to decompose the relation, we need to identify the functional dependency. Here, before decomposition, you need to ask two questions. Here, based on functional dependency only, we are going to decompose. Here, now we are discussing about the normalization. Here, normalization, already I told you, normalization is a mechanism. The Codd, C-O-D-D, Codd is a scientist or author for this normal forms, actually database management system. Codd proposed so many rules. Based on so many rules, here our academicians, maybe the Raghu Ramakrishnan, fourth, they are divided into 5 normal forms. Actually, Codd proposed so many. Actually, that proposed by Codd rules. CEO or the Codd rules actually. Now we have, as per our academics, as per the syllabus, we have 5 normal forms. Yeah, before entering into the normal form, first of all, we must learn normal form. Before going to the normal form, again I am telling all normal forms are going to help to decompose the relation. Are you clear why I am discussing this normal forms? You are going to decompose the relation based on using these normal forms. Are you clear? Are you clear?
Yes,
Yes,
sir.
sir.
Why we are decomposing? To avoiding of the redundancy. Now, indirectly, as per the transitive rule, you can tell here normal forms are going to avoid the redundancy. Clear? All of you clear? Normal forms are going to avoid the redundancy. Clear this? Hello?
Yes, sir.
Yeah. Normal forms are going to avoid the redundancy. Okay, now, when you want to decompose the relation, yes, we have to decompose the relation based on the normal form. Now, if we want to identify that given relation is in which normal form, based on the normal form rules, we are going to decompose the relation. Now, that normal form identification will come based on the functional dependency. Remember, this point is very clear. Whenever you are going to check that particular given relation is in which normal form, you are checking. When you want to check, before checking, you need to identify all functional dependencies in that relation. Once identification of all functional dependencies, nothing but strong rules, maybe the strong sound rules, that is F, and a closer set of functions, that is F plus. All you need to identify, based on the functional dependency, we can find the that relation is in which normal form. Once you identify that normal form, now you can apply the rules of the normal form and decompose the relation. After decomposition, you need to check. Before decomposition is what? You need to check that relation is which normal form. Yes, you are checking the normal form. Here, after decomposition, what you need to check? Here, two things we have to verify. One is, what are the two things? Tell me after decomposition, as per last class. After decomposition, with help of normal forms, what is the rule? What is the two things we need to check? Very important. Hello?
Lossless join.
Uh, Lossless join? What is lossless join?
Dependency preservation.
Dependency preservation. Very good, Anisha. Lossless join means after decomposition, when you want to join, then there is no data loss. That is a lossless join. The dependency prevention means dependency preservation. Means one relation is depending on another relation. That is nothing but a common attribute. So these two things must be there after decomposition. So that is what. Now, I said just now, normal forms always depending on the functional dependency. Sir, can anyone tell what is functional dependency? What is the meaning of functional dependency in this relation model? Any one of you,
Any
please?
of the attributes depending on other attributes.
Yes, in a relation, one of the attribute or some of the attributes are depending on single attribute or multiple attribute. The single attribute is depending on single attribute sometimes, multiple attributes are depending on single attribute sometimes, and multiple attributes are depending on multiple attributes sometimes, or single attribute is depending on multiple attributes. Sure, whatever it is, but attribute is depending on other attribute. That is called functional dependency. Is it clear? Is it clear?
Yes, sir.
Yeah. Now today we are going to enter into the normal forms. Very important. That's why I have given this much introduction, and I've given this much importance because it is there everywhere. When they are going to start everyone, they are going to start question from DBMS. Without normal form, they cannot end the interview. Please. Now coming to the normal forms. Generally, the normal forms or normalization. Okay, form means form 1, form 2, form 3. So generally, it is called as normalization. The normal form is a state of relation. Same different definitions I am going to read. You can add your own definition also. I have written so many definitions for these normal forms. The normal form is a state of relation that results by decomposing that relation for a good design to avoid redundancy. Yes, exactly right. Whatever I told you, same, right? Yes or no? Maybe the English sentence is going to change. The meaning is same. Is it clear? Is it clear? Please, this normal forms one by one, you need to apply your database. That is the third experiment. All of you clear? Hello? Hello? Is this screen is visible?
Yes,
Yes,
sir.
sir.
Right. Is this clear? The different definitions I am going to read, then you can map exactly whatever the knowledge you are having and improve. Clear?
Yes, sir.
Hello? Yeah. Normalization is a process of deciding which attributes should be grouped together in decomposing a given relation into smaller relations. Exactly right? The normalization is decomposition. Means we have to group it together of related attributes. That is a functional dependency attributes you have together into one relation. So this is the meaning. Another way of definition, another way of analysis. Here, one more way also I can tell you. Normalization is a process of decomposing relations to produce a smaller and well-structured relation. Exactly. It is a well-structured because we are avoiding the redundancy. We are getting the smaller relations. So that's what it is a well-structured relation. Sure, normalization is a tool. Yes, we can tell it is also a tool to validate and improve a logical design. Exactly. So whatever the relation model you are converted from the ER model, after relation model you are implemented SQL queries, we are telling it is a logical model. Correct? From relation model to you are executing your queries, create table or whatever the radial and manual commands you are using, and you are creating a database in a machine. That is a logical design. Yes or no? Yes or no? Hello?
Yes, sir.
Yeah. Now that if you want to improve that logical model, if you want to improve, you should use normalization mechanism before implementation of logical design. After relational model, you must apply normalization mechanism on relations. Then you will get the decomposed, well-structured relations. Then on that you apply your SQL queries and create the logical database design so that it satisfies certain constraints that avoid unnecessary duplication of data. 100%. So we are going to avoid the unnecessary duplication of data. That is called redundancy. All of you clear different perspectives of normalization? Hello? All of you clear? Hello?
Yes, sir.
Yeah. There's some other way of representation also I'm going to explain. Normalization is the process of organizing the data in the database. Exactly. Normalization is used to minimize the redundancy from a relation or set of relations. It is also used to eliminate the undesirable characteristics like insertion, deletion, updation, anomalies. Normalization divides the greater divides the larger table into a or greater table into smaller tables and links them using relationships. Exactly whatever I told you. This is another definitions what I am telling. The normal form is used to reduce redundancy from the database table. So finally, this is the main information. Normalizations are going to reduce the redundancy. All of you clear about the normal forms and its definition, why normal forms are required, what purpose we are going to use, and what are the definitions we have for the normal forms. All of it clear? Even you can write your own observation and you can write your own definitions. So these definitions, I written my own observation. So this is bookish definitions. All of you clear about that? Now, what normal forms and why normal forms? All of you clear?
Yes, sir.
Yeah, very important, yeah, please remember. Now coming to the normal forms. Here steps in a normal form. Why I mentioned these steps? Here books are never mentioned these steps in a normal form. Books are going to refer types of normal form. Directly they will come. Here why I should mention these steps, I will come later. Okay, you can understand why I mentioned this. Here practical orientedly I was evaluated this normal form. That's why I have taken steps. I will tell you, don't worry about this. The types of normal forms. Here we have basically not four, actually, this is five types of normal forms. Here one is first normal form. 1NF means shortcut name is first normal form. Second normal form. Third normal form. BCNF. Next fourth normal form. And fifth normal forms are also there. I will tell you, don't worry. All normal forms I will tell. So basically six normal forms are there. The first normal form, second normal form, third normal form, BCNF. So actually, these are core up to BCNF. But after BCNF also, there is a chance that is modern database design. We have fourth normal form and fifth normal form also. Are you clear? In syllabus, they mentioned fourth and fifth normal form. Why? It is a modern database design. We have fourth normal form and fifth normal form. In old databases, there is no this fourth normal form, fifth normal form. That's why your books are going to refer up to BCNF only. All of you clear? All of you clear? Hello?
Yes, sir.
Hello? Yeah. BCNF is a scientific code. This is a Boyce-Codd. Already I told you, this all normal forms is supported by code only. Boyce-Codd normal form, BCNF. All of you clear six normal forms? Now we will discuss one by one. Today, first normal form I'm going to discuss. All of you clear this?
Yes, sir.
Yeah. Now, sir, we can start from first normal form directly, but before starting, sir, I will tell you when you are going to apply normal form, you can feel as a steps. Means the question it will come like this. Your given relation, you must be avoid or you must be apply the normal form. They will give one relation and they will ask you in interviews or somewhere, please apply the normal form or convert it into the normal form. Like that. Sure, then how should we use? If you learn directly first normal form, second normal form, third normal form, like that, if you do that, we cannot have such type of knowledge. Sure, the meaning is the given relation is having redundancy, so that you need to avoid the redundancy. How to avoid the redundancy? As per the now technically, how to avoid the redundancy? Hello? How can we avoid the redundancy?
By using
Decomposition.
relations.
Hello? By applying of normal forms, remember. Here, by applying of, hello? As a database management system learner, SQL learner, now you must tell, by applying of normal form, we are going to avoid the redundancy. Are you clear? All of you clear?
Yes, sir.
Right. Now, how we know that relation is in a which normal form I should apply? Because we have 6 normal forms, right? Yes or no? As per the discussion,
Yes,
we
sir.
have 6 normal forms or not? Yes or no? Hello.
Yes, sir.
So that whenever one relation is comes to you, then you need to follow step by step. Means step in normal. That is what I have written steps in normal form. Means first you check that normal form is in that given relation is in first normal form or not. If it is not in the first normal form, then you must apply first normal form. If it is in a first normal form, then you must apply check that is in second normal form or not. If it is in a second normal form, rules are there, then you go for third normal form. If it is not in a second normal form, then apply the second normal form and check the third normal form. So that is what. Here like that, here we need to check that particular relation must be in a all the normal form, then you can tell that relation is avoided the redundancy. You don't think directly I am going to apply this relation to the fifth normal form. No, you need to check step by step. First, you need to check that given relation is in a first normal form or not. If it is in a first normal form, then check the second normal form. If it is not in the first normal form, apply the first normal form rules. If it is already in a first normal form, then check that is in a second normal form. If it is not there in the second normal form, then apply the second normal form rules. Later, apply the third normal form. Like that, you need to fix this relation and apply this relation step by step, all normal form. Finally, all normal forms are going to satisfy on that relation. Then you can stop your applying of normal forms. Then you can decide that that relation is avoided. Not completely, we cannot remove the relation. Already I told you here, until unless if you find the functional dependency, you can apply the normal form. If you are not identified any functional dependency on the relation means you cannot apply any normal form. And you cannot remove the remaining redundancy. All of you clear now? That is what I told here. I have written in my notes here steps in a normalization. All of you clear? How to apply? All of you clear? The procedure is clear, everyone? Hello? Respond quickly. Hello? Are you there?
Yes, sir.
Clear this? I'm not getting any. Yeah, okay. Please respond, then only you can understand. Right. Now, today we are going to learn first normal form. Please learn practical oriented. Don't learn the theoretical, please. Your first normal form, very simple normal form. Here, please, whatever the normal form here we are learning, please apply in laboratory third experiment. So don't waste your time. I don't want to discuss again this the third experiment. Please do it. I will verify your all record and observation on coming Saturday. This normal forms third experiment is applied or not. Seriously, I'm telling. How I verified, same day, all these normal forms you should apply. Whatever the normal form we are going to discuss, and remaining things also we need to apply. Right. So now, first normal form, very simple normal form, very easy normal form. A relay, just I am reading, then I will tell you with example. Don't worry. A relation schema is to be in a first normal form. Means if you are going to feel that given relation is in a first normal form, if the values in the domain of each attributes of the relation are atomic, means values of that attribute, every attribute of relation, values must be atomic. Atomic means what? Tell me anyone? Hello? What is the meaning of atomic? If
Single value.
single value, very good, Abhilash. Means if you are thinking the given relation is in a first normal form, means every attribute in a relation, every attribute, each and every attribute in a relation contains only single value. If any attribute is having more values, for example, if I return phone number, you people are having 2, 3 phone numbers, you entered 3 and 4 values. If that is not a first normal form. Understand? Every attribute contains only single value. Understand? All attributes, not only single attribute, all columns otherwise. Clear?
Yes, sir.
Yeah. Again, I will give some more other information. In other words, only one value is associated with each attribute, and the value of that attribute is not a set of values or list of values. Okay, those values are not a set of values or list of values. That attribute contains only single value. That is a atomic value, single valued attribute. Already we know in a ER diagram, here that attribute is a single valued attribute. Means if the relation is in a first normal form, means if it is not there, you need to convert. How to convert, I will tell you. Don't worry. If you want to verify given relation is in a first normal form or not, just check all the attributes are single valued attributes or not. Means every attribute contains only one value. Understand? Already you know ER model. All of you clear? Hello?
Yes.
Now, first NF, 1NF states that the attributes must contain only atomic, that is simple valued or individual valued, and the value of that attribute is a tuple must be associated only with a single value other attribute. So this is the meaning. So now I will show you a bookish definition and examples also. A relation will be one enough if it contains an atomic value. It states that an attribute of a table cannot hold multiple values. It must hold only single valued attribute. First normal form, this allows the multi-valued attribute. Here, this definition, please indirectly, so many information I am giving here, interviews people will ask. First normal form, this allows the multi-valued attribute, composite attributes, and their combinations. Here, first normal form, it never allows multi-valued attribute, composite attribute, and their combination. Means first normal form allows only single valued attribute. Means remaining all other attributes it is going to avoid. First normal form only accepts single valued attributes. Remaining category of attributes it never accept. Clear this? All of you clear? All of it clear? Hello?
Yes, sir.
Right. Now, one example I will show you. Here, this is an employee table. Here, employee ID, employee name, employee phone number, employee state. Now, employee ID is 14. Now, employee name is John and employee phone number. He is having two phone numbers. So that he entered two phone numbers. Now, Harry, only one phone number. Sam, now again two phone numbers. Means this attribute, employee phone number, or any other attribute also. But here in this example, this employee phone number is accepting more than one value. Means it is avoiding the rules of the first normal form. So that is, every attribute must accept only single value, but this attribute accepting more than one value. So that this is going to not in a first normal form. It is not in a first normal form. It is overcoming the rules of first normal form. Clear? All of it clear? Hello?
Yes, sir.
Yeah. Now, so how to convert this table into the first normal form? How to make it this table into the first normal form? Means just instead of taking this multiple values for this attribute, you take single value. Means you can increase the number of records. Means yeah, this 14, this record you need to write two times. One is for first phone number, another is for second phone number. Sam also, one is for first phone number, another is for second phone number. Now you can get 55 records. 14 John, first phone number, 14 John, second phone number. 12 Sam, first phone number, 12 Sam, second phone number. Now this is in a first normal form. So this is not in a first normal because in this relation, every attribute is accepting only single value. So that directly, blindly you remember this. So what is happened, further consequences we will discuss. Now simply, it is a first normal form. Clear? Then how to convert a given relation is not in a first normal form, how to convert to first normal form. All of you clear? With example? Hello? All of you clear
Yes,
this
sir.
example? All of you clear this example? Hello?
Yes, sir. Clear, sir.
Yeah. One more example also we will discuss. Here, one more example is another course table actually it is. Now ID name courses. Now ID name courses. Now here ID is one, name is A courses. Means that a student is going to take two courses, C1 and C2. Maybe there is a chance here as a student you can opt 6 courses in the semester like that. There are many courses we are writing in the same courses attribute. So this is first normal form. Is this relation is in a first normal form or not? Is this relation is in first normal form or not? Hello?
No, sir.
No. Why? Why? Which attribute is violating the rule?
Course.
Huh?
Courses.
Courses.
Courses attribute is violating the rule because it is accepting multi-valued attribute. So that we need to convert this relation into the first normal form by adding some more columns. So that I have taken A for course 1, course 2, M for course 2 and course like that. So that it is in a first normal form or not now? Is this relation is in first normal form or not?
Yes, sir.
Yeah. Yes, it is a first normal form. Any one of you tell your observation of this first normal form after conversion of relation into the first normal form? Is there any drawback? Anything is observed? This is before normal form, first normal form, after normal form. So any observation is there? After conversion of first normal form, is there any drawback even from here? So this is the first normal form. So this is the before first normal form. So is there any observation? What is the drawback?
The same tuple is being stored again. Redundancy.
Can you repeat again?
The same tuple is being stored again.
Yeah, means redundancy is increasing. As a technical guy, you tell like that. Okay, your answer is right. Yes or no? Redundancy is increasing or not? When you are using first normal form, the redundancy is increasing or not?
Yes.
Because here only one time John is there, one time 14 is there, one time Sam is there, one time 12 is there, one time UP is there, one time Punjab is there. But what happened here? John and employee ID and UP is increasing twice. Means redundancy is increasing. Means here using first normal form, there is a chance of increasing of redundancy. This is the drawback for the first normal form. Understand? So people will ask, what's the drawback of first normal form also in interviews? Yeah, here also, they're increasing. Okay? Increasing or not? Hello? Increasing the sure, A two times, M two times. Redundancy
Yes,
is
sir.
increasing or not? Yeah. The redundancy is going to increase because of first normal. Here, not only this way, even some people will write a table in another fashion. I will show you this fashion. That is also not in a first normal form. How it is? So just I have drawn here. So some people are going to concise total data into a required format. For example, their faculty, department, and professor name, and courses preferences. Now this is a table name. Again, this column, this particular attribute is divided into two attributes. So this is what, which type of attribute it is? Descriptive, sorry, derived attribute. Yes or no? Yes or no? Hello? Courses and course department for course preferences. This is a derived attribute or not? Course preferences is derived from course and course department. Hello? Hello? Is this my voice is audible? No one is responding. Hello? Hello?
Yes, sir. You know.
Ah, all of you understood here another example, another different category. You are not only this, your book is going to tell, but here real time examples I am discussing now. Here sometimes when we are going to prepare one data in a tabular fashion, here like this we can prepare. Yes or no? Course preference is a uh, derived attribute or not?
Yes, sir.
Yeah. Now in this way, now professor, maybe faculty, here all computer science related faculty I will take in this first column. Sam and Anwar. Now Sam is going to have handle three courses. Anwar is going to handle some of other courses. Now like that, we are going to construct one table. But this table is in a first normal form. Is this table is in a first normal form? This relation, given relation is in a first normal form?
No,
No.
sir.
No. Why no? Why
And
no?
it is multi-value. Course preferences is multi-value. Okay.
No, wrong. Your analysis is simple. First normal
First
form,
normal
what it
form
contains?
develops a multi-value.
First normal form, what should contains? Exactly.
Only atomic.
Yeah, first normal form contains only atomic values of all attributes, single valued attribute. Remaining all are going to avoid. That you remember. So that here there is some multivalent attributes in this relation. There is some descriptive attributes and there is some combination of attributes. So many attributes are involved in this relation. Yes or no? Yes or no?
Yes, sir.
So that it is not a first normal form. Then how to convert this normal this relation into a first normal form? Simple. You need to take all the individual attributes, that is faculty department, professor name, course, and course department. Yeah. Faculty, professor, department, department here, department, professor, course, faculty department here I have taken, course department. Anyway you can take it. Now individually you need to take. Now every specific value you need to mention for every tuple. The SAM 353 CS. Maybe there is a chance of redundancy. I have to accept. Already I told you. But first normal form must contains all attributes must be a first normal form contains all attributes must be a tell me first normal form
Atomic
contains
levels.
atomic values please means that because of this atomicity attributes maybe there is a chance of redundancy of data in a first normal form even though we need to apply first normal form. All of you clear about first normal form clearly? All of you understood this first normal form?
Yes, sir.
Still anything is there, please ask me. Because if you understood first normal form, then we are going to discuss next class on our second normal form. I don't want to enter into second normal form because first of all you need to understand normalization and you need to apply first normal form to your already you are having databases. You must apply first normal form so that you can get some idea. So that we can apply slowly second, third, fourth because it is very important. So practically learn, don't learn theoretically, please don't learn by reading, please learn by practicing. That is what my intention and you will get good knowledge. And don't think only this knowledge is only required for academics. It is required, more required for your placements, your, your industry. When you are joining industry, these things are very, very important. All of you understood this normalization today session? Normalization, why normalization, when should we use normalization, and what are the normal forms, and what is the first normal form, and if it is not in the first normal form, what should we do? Clear?
Yes, sir.
Here, if you are having any relation in your database, ask me so that I can give the clarification. In your database, if you are having any relation for the first normal form, it is there or not, you ask me or you show me, then we can, I will tell you one solution, then you can understand more, everyone. Any one of you. How should we apply first normal form? We can understand. Hello? Here, anyway, one thing you are observed. Is there any chance of key attribute is having multi-valued at multi-values? This type of questions also they are going to ask. In your relation, all are key attributes. Is there any chance of multi-valued multi-values are going to access by any attribute? Tell me the answer. In your relation, I am repeating, in your relation, all are key attributes. Is there any chance of multi-attribute of that attribute? Hello? Is this clear? My question is clear. Hello?
Then we can't apply.
Because? Because
Primary key
already,
attributes
yeah, key attribute is nothing but it is a unique. it always going to expect only the unique value. So that automatically that relation is in a first normal form. Are you clear? There no need to check even it is in a first normal form or not. If all attributes are key attributes, then directly that relation is in a first normal form. Such type of questions are going to come from your interview. All of you understand? All of you understand?
Yes, sir.
Yeah. So please try to apply. My sincere suggestion is please try to apply this first normal form on your database for as a third experiment, and you learn more